Hi guys, so as I mentioned, we're going to look at volume of a polyhedron today. And the couple main ideas we're going to talk about is what is volume, visualizing volume in the world, how do we calculate volume, so you're going to get your formulas. We're going to do prisms versus pyramids and cones, and we're going to talk a little bit about the space taken up by a 3D shape. And that's really what volume is. A couple examples of volume would be the amount of water in a fish tank, the amount of air in a balloon, also the amount of sand on the beach actually takes up volume, right? Because sand has depth to it. It's not just one layer of tiny, tiny grains of sand. So, what we've got here are a couple of volume formulas. And what you need to know is how to read these formulas. So for a cube, the volume of a cube is S cubed. That is a side length cubed. S is a lowercase letter. Lowercase letters stand for a length. And that is the length of a side for a polyhedron. That means you're looking at a flat surface of the polyhedron, one of the surfaces, and you're measuring the length of that side. Now, if we take a look at the volume of a rectangular prism, we have volume equals length times width times height, or we have volume equals base times height. Now, notice the base is a capital letter. Capital letters stand for the area of a side. So lowercase letters stand for the length of the side, capital letters stand for the area of the side. And if you think about it, this makes sense because for our rectangular prism specifically, the small letter formulas, length times width. Well, length times width is actually area of a rectangle, which means the area of my base is equal to length times width. So I can write this formula in two different ways. This will happen with a couple of your more complex polyhedron formulas as we go. Again, I'm going to remind you that pi is equal to approximately 3.14, and you can always write it as the pi symbol. You never have to interpret the pi symbol in any sense. So please make sure that you leave pi in the equation and you're not losing them at all when we're progressing. A couple of things about prisms versus cylinders and pyramids versus cones, okay? A prism is a three-dimensional shape that has a base, and the base is usually one of the sides, one of the surfaces, and you can basically take that surface and project it through the shape. So for my rectangular prism, I want to see if I can illustrate this for you here. I have a side of my rectangle. It is a surface. This rectangle can actually be shifted all the way through the shape, almost like a window pane, and it's going to equal the back side of the rectangle. So I can pull it from the back, to the front, and all the way from the front to the back. And what it tells me is that the height of my rectangle is consistent all the way through. So you're all set in terms of understanding how that shape progresses. Also, if we look for a moment at a cylinder is in fact a type of prism because the circle in the cylinder can be shifted all the way up through the cylinder and equal the top surface of the cylinder as well. So it's almost like I have millions and millions of slices in my cylinder. It's very similar to having lots and lots of cylinders in lots and lots of circles, within my cylinder. It's almost like I have all of these little layers. Like, I don't know if anyone's ever had like a trifle cake. There's lots and lots of layers to it, or even just a regular layer cake when you think about it. It shows you that the cylinder has all these circles that project upwards through it, and it's consistent. In terms of a pyramid or a cone, this is not the case because I can take my circle and put it in the base of my cone, but as I rise it up, the circles that travel throughout the cone are getting smaller. They're actually shrinking, right? I'm getting this tiny, tiny little circles at the top of my cone. So as I progress upwards, they're getting smaller. It's the same circumstance with the square base at the bottom of my pyramid. So I have a square base on my pyramid, which is not quite the same size as the square midway through the pyramid, which is not quite the same size as the square at the top of the pyramid. So the difference between prisms and cylinders compared to pyramids and cones is that the prism and the cylinder can have a shape progress all the way through the polyhedron and stay a constant size, whereas a pyramid or a cone, the shape is there, but it's shrinking as you progress through the polyhedron. So that's just something interesting that I thought you might like to know in order to differentiate between pyramids and prisms and also cones and cylinders. There are a couple examples right here. I just want to show you quickly some of the formulas and some of the explanations. So the volume of a rectangular prism is length times width times height, or again, the base times the height. So if you substitute any of these values, you can say I have 6.3 times 10 times 33, and that will give me the volume of my rectangular prism. The volume of my cylinder is the area of the circle formula, which is pi r squared, and then that's multiplied by the height of my cylinder because I need to account for all those teeny tiny circles that are projecting up through the cylinder. So in this case, I would have pi times my radius, which is 8 squared, times the height of my cylinder, which would be 56. In the last two cases, in terms of the pyramid and the cone, you are going to want to look back at those formulas, and I'll show you the formula for the pyramid is 1/3 times the slant height squared times the height, and you can plug that in. And the volume of the cone is actually very similar to the volume of the cylinder, but it's multiplied by 1/3, and that is because the cone actually takes up 1/3 the amount of space as a cylinder, and we'll experiment with that a little bit in class next week. So please make sure you complete those examples. I do want to see them finished in your notes, and enjoy your weekend. Bye, guys.